Alcohols react with organic as well as inorganic acids to produce compounds known as esters. And the reaction of alcohols with the carboxylic acid, that is an organic acid, will give us an organic ester, which are typically referred to as only esters. So if we take an alcohol and a carboxylic acid, an elimination of water will give us an ester final product. And these esters will be a subject of much of our discussion in our in chemistry 33-32. At this point, suffice to say that this reaction is reversible, and because of the bond strength being roughly equal on both sides, and is not very often used as a preparative source of esters. Instead, more active carboxylic acid derivatives, and these will be these acyl chlorides, react with alcohols irreversibly to form esters as well. And these acyl chlorides are produced from the acids themselves through the reaction of thionyl chloride. Now, the interesting piece, the only interesting piece of information that we will give in this course about esters is that they smell nice, and a lot of fruity and flowery smells actually come from esters. And so I'll give you some examples of nicely smelling esters, such as this ethyl butyrate, which is part of the aroma of bananas and pineapple, as well as strawberry. This compound, which is slightly more complex in its alkyl group, is part of the aroma of peach. This formate ester has been observed in raspberries. And finally, this slightly longer chain ester has been isolated from apricots as well as pears. As I say, that the common motif in structure is present in all of these. Some of the esters, such as ethyl acetate, are also very common solvents, and so in general they're a relatively important and interesting class of compounds. They also find a lot of applications in biology, but we'll talk about all this and much more in 33-32. In the next subtopic we will cover inorganic esters, so the esters that alcohols forms with inorganic acids such as sulfuric, nitric, or phosphoric acid.